Yes, so this is the assignment we need to do. We need to predict the price of the car. So the car data is given to us. So different cars sold at different times and different models and what their range of age and everything is given. So for that Excel file, we use the Excel file to predict a new car, how much it is going to value. So that's the first job. So let me do one thing, walk through you. So the first thing is we will build a regression model. So that's the first job. And second job, we'll plot the residuals. And the third job is we'll predict the sales price of that two cars mentioned. So this data is there in this link. Click on the link, download the file. So save it. So here downloaded the data. Now you open the folder, click on the file. So I got the data open. So now I see there is a description about the thing. So what is the car is all about. So and there is a data. So this data shows that this car was sold for this price. This car was this type of car, like which is having 23 years old, 10 months, 73 kilometers run, and horsepower, and the color, and is it automatic or the radio. So different cars are sold with a different price. It is a history. So using this history, we are going to predict the future car. Like somebody want to sell a car like this, which is having these features. What price he will get? That's the first question. So we already having a history for different features cars, how much price it went. So now we are going to predict that. So how we are going to do that? So that's the question. So here we need to understand the regression model. So linear regression. So the linear regression means this, suppose you see house price versus house size. So somebody has sold his house which is having a 400 square feet this much price. Somebody sold a house of 800 square feet at this much price. So if you plot the data and we'll have a marking points map. So when you draw a line that fits between the data points, you will get a line. So this line we call it as a linear regression line. So this line will help you to find out the data. Suppose you want to use the point here. So what is the if this one 1500 square feet is there, how much price I will get? So if I point onto the map, I point onto the y-axis, I will get the price. So for this 1600, 1500, I will get this much price. So if I know the relation between x-axis and y-axis, I can know what price it will go at different points. Okay. So let's say if 1000 is a square feet, I can predict that it would be around 35,000, something like that. So if I have the relation, so the relation between these two is a line, right? So the line indicated like this, y equal to mx plus c. M is the slope of the line. So m is the slope of the line. So the slope of the line, so that's relation we need to see. going to show you the picture which I downloaded. Where it is downloaded. Yes, so the slope of the line indicated like this. So this is the slope. So that's the slope. And this is the constant. So when you draw the line up to the connecting all the points, best line you can draw. So this is called the base, means even x value is 0. That means even less square feet house, it will get a minimum price of this one. So y-axis. So this line. So this is what we call it as a linear regression line. So, and I want to see my Excel file. We want to develop what is the relation between total price with this age. And we want to see what is the relation between months and what is the relation between the kilometers. Suppose you see this car has gone for 1 lakh kilometers already. And what is the price I may expect for this? It is already sold at this. If similar car comes, what will be the price? So that if I know the relation between these parameters with this, I can easily predict what is going on. Okay. So now that is the task for us. So this is the history we have, and this is the data he provided. He wants us to calculate what price I can sell this car having these features. Okay, so that's the important thing. So let's go and see the linear regression. So this is equal to y mx, means x is x-axis and m is the slope, what we've seen in the figure, the slope of this line, and so that's a relation between two variables. If we know, we can find each other. If we want to know the y house price, I can know the house price for a x square feet house if I know the slope and if I know the c. So our job is what is the constant c value and what is the slope value, and the slope is called as a coefficient and the constant is called as an intercept. Okay, so the slope and constant. So y equal to mx plus c. So x is a variable and y is the output what we want to predict. So now let's see. I go for Excel linear regression. I'll show you clearly. And before you do anything, the first step is you open the file and you note down each and every step here. So I will mark this as x0 variable column and I will drag this one up to this point. So to note down what is the variable, this variable I call it as x1, x2, x3, x4, x5. So like that I have all the variables mentioned here. So that's the first step I do. So to indicate this variable as x1, so I want to know relation between x0 and x1, x0 and x2, x0 and x3, and x0 and x4. That's the coefficients. The slope between these two is coefficient. So I have a data. So if I plot these two, suppose if I plot a linear graph, let's say, so no. no. Okay, sorry. So if I draw the line between these two, I will know the plot, how it's going on. But let's see how we do this task, predictive analysis. The first step is you note down, you label the columns. The first step is label the columns, and second step is install. So install data analysis tool in your computer. So I'm showing you install data analysis tool in your Excel. So for that, you need to go to File, Options, Add in, File, Options, Add in, Add in, and in that I have a analysis toolkit. You see analysis tool pack.
Please, can you enlarge your screen? I can't see where you went to, please. For file.
See, enlarging is not possible. Maybe these things because the file is here. So after recording, you will be knowing easily when you can see in the video easily. Okay. In the file is on the top of the Excel. So you see file, home, insert, file, options, add-ons, analysis tool pack, and you need to say go. So when you click on go, and you will see the window like this. So the window, you need to select the analysis tool pack and click OK. So now when I go and see in data analysis, so I have file, home, insert, page, formula, and data analysis tab. In the tab, I have a data analysis tool. So you need to see this data analysis tool. So when I click on that data analysis tool, so I have a regression tool. Yeah, you can see the regression here. So the regression tool, I have a regression tool inside the data analysis. I click OK. Now it will ask me Y range. Y is the things which we want to predict. So we want to predict the Toyota price car for future cars. And I have a history here. So I want to select this thing. So I put on here and I drag on up to the end. So I drag up to the end. So I got it. So now the input range should be all the variables I have. So I have all the variables here. So all of them, apart from the Toyota, remaining all will come in X range. So I selected the entire table of X range from here to till the end. So I will put a labels. So I selected labels also. This labels also there. So I will select the labels also included. And where I want to put it, I want to have a new worksheet with a regression analysis one. So I want to have a new worksheet. So I can click on a residuals. So it will give me residuals also. I will tell you what is residuals. So when I click OK, it will give me a data like this. So don't worry, it's not a big data we want. So, so when I have that one, so you enlarge the columns or you can select all columns and the column width to 30 or you can decrease that to 20 less. Put it. So I select all columns and put the width 20. And now it clearly tells me what to do. So now the regression model was built. So the first step in the here, the build regression prediction model and choose the best model with highest ratio for acceptable P. So the P value he mentioned here is 0.5. So now this is the P value. So the first step is see which parameter is having P value greater than 0.5. So for that, I put a formula equal. So click on a cell where you want to check the condition equal if bracket and select the P if what happened? You can click if logic means if P value is less than 0.5, I want that parameter for my analysis. If P value is greater than 0.5, I don't want. So I put significant. If it is true, if this is true, that means P value is less than 0.5. That parameter is very important. And if P value is greater than zero point 0.5 is not important, so not significant. So when I press it, so I got significant and so I got this parameter is very important. This intercept is very important because the p value is less than 0.15. So this parameter is important or not for my analysis. I will check. So you come here, you will see plus sign. You drag it like this. So it will automatically apply the formula and tells which parameter is important. I will column that as importance. So let's put it that way. I color it so for our understanding purpose. So this is important or not important, we will filter. So I want only the significant variables for my next stage of analysis. So significant is I can filter it, go to filters, select the column, the row, and go to filter, put the filter and filter it. Significant, not significant. So I will select the significant one, not significant ones. So I see these four variables, five variables are not important for my prediction. So they're not impacting me a lot. So what I do is, so I take this data and make a copy. So I right click on the tab here, right click on the data tab and move and I create a new file. I create a new file, create a copy of data sheet. So I created a data sheet 1 and data sheet 2. So data sheet 1 having my original data and data sheet 2 I'm going to delete these columns because they're not important for me. They're saying they're not important. So what I do is so I will apply them or you can copy this data. You can copy this data and come here from here, you select this cell, put it here, and you have option called transpose. So I'm telling you again which column you want to delete. So you need to identify which column you want to delete. So you copy this cell, you copy this entire thing, copy. This is very important step. So I go to my second sheet where I want to do the performance. So I have one column on top of it. So now I paste here. Right, I select this cell, right click. Instead of pasting, I use transpose. Here transpose will convert the column items into row items. Now I can see which is important and which is not important. Sorry, it's not copied well. Oh no. For this, you have to copy and paste here as the values and take the values again, copy it and come to here. So you can do it any time easily. You can check. So now which one is not significant, which one is significant is shown. So I need this one, 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 and it shows I don't need this. So that's what the data is telling. So the regression analysis is telling me here for p-values met color is not important. So I can confidently delete this column. And this is significant. This is not significant, so I can confidently delete this column. And these four are not significant. So I got all of them, the significant. Now my second stage of data came. So now again I will do the regression analysis on this. So until I get the p-values are less than 0.15. So I want to see all of them are significant. So until I achieve that step, I will do the regression. I will do this regression analysis and I get until I get R square value or the multiple R value greater than 9. Until that I do this. So now you forget about these two, we already came to the second stage. We got some significant data. Now let me analyze again. Go to data analysis, do the step, regression, okay. Now the same way I want to select it. It is already selected. The y-axis is the price prediction. And this one I need to change because I deleted the column, so I need to change the new columns. So I selected everything and I enter it. Sorry. So now I also use the labels and the residuals and everything. So at this stage, I don't need a residual because I already developed them. So in the regression analysis one. So this is my regression analysis two, second stage I am doing. Okay, so now I will click on this. So again, it given me the second file which shows the all the t values and p values, lower and higher. So again, I do if condition if any p value is greater than 0.15 because by seeing it I cannot say. So I apply if. So the formula is written equal if bracket the p-value of the cell is less than 0.15. If it is 0.15 less than, it is significant, means important for me. That cell is important, and second is not significant. So it's not important. So let me put it. So the first cell is important. The first parameter is important. So now, so I can drag the same and apply. So all are important. So now I reach the stage that I cannot delete any column because all columns are important for my prediction now at this stage, because all columns have a relation with a car price. They have a close relation. The P indicates how close they are. So it's having a close relation. So I need to use them in my equation. I need to use them in my equation. Okay, so now the equation would be the intercept. So the equation would be intercept for our understanding and writing plus, and this is the coefficient of the edge. So these are the coefficient of the edge, and that's multiplied with a coefficient value. So we'll see how it goes. So these are the intercepts we have, intercept and coefficients. As I told you here, we have a y value. We need m is a coefficient and c is a constant. So intercept is a constant for the price what we want to predict. And x is this one, and the coefficient is this, and x value is this one. Okay, you understand? Yeah. So now let me put some more here. So to check our equation is correct or not. So what we do is we paste there all the coefficients. So I copy these coefficients again and I put it on top of the data. I transpose them. So now when I transpose, I know this coefficient belongs to this edge value. This coefficient belongs to this edge value. And the relation between this and this is having this slope. Okay. And the relation between these two is with the slope. And the relation between these two is with the slope like this. Okay. So let me put the equation equal to, my first equation is intercept. So this is the basic constant what I have. Even the car is not having any features like this, I will get a minimum price of this one. So that's the thing. So that should not be changed. So you have to freeze that formula. You press F4. It is nothing but you use a $2 means you freezing that cell. So it's very important step. Plus and take this coefficient multiplied with this. So this is nothing but y equal to c plus mx, or y equal to mx plus c. Y equal to mx plus c. So this is, so but I have a more variables. So I have a more variables. So I have a m1 x1. M2, X2. So I have a M2, this one, and X2, this one. Plus I have a M3 and I have a X3. I have a M4 and X4. I have a M5, X5. So G5 into, yeah. So I have this guy, I have this guy, I have this guy. So this will be easy to formalize the thing. So this is the predicted value. Now, now to check it. So now for first this car, I manually predicted using this formula. I got 1400 So now let me see what computer has generated this predicted value. So come back to my first step where I have done all these things. Here you see, so the first thing the computer did is it predicted a value of this one. I just zoom it. It is it related to first data. So this first cell, the computer is predicted the price is 14,676 and my analysis predicted 14,663. It was very close and that was the $11. And the computer uses the P condition is less than 0.505 here. So the P condition it uses more regress and it gives a more accurate value. Now let me drag this. So here it's very important to freeze your coefficients. F4 you click. Yeah, so you need to freeze the coefficients. That's a these all are coefficients and C1 and the D1 and the E1 and the F1 and the G1 and the H1 and the I1. So these are the coefficients where I pasted them. So you enter. So now you double click on it. You see the computer is predicted the price using this formula. This C, the intercept or bias or basic price, and this all the relation between the price to the each column. So age, what is the price and age effects? Suppose if it is a old car, obviously there is a there will be negative effect on the price. So I got a negative. If it is a manufacturing month is old, so this is age and month. And if it is a kilometers, definitely there is a negative impact. If the horsepower is more, it will be positive. So these are all features. So computer don't know these details. It only predicted using these details. Our formula, we predicted the price. And now this is called predicted value for all the data sets. So now what is the residual? Residual is the difference between actual price and predicted price. So maybe the prediction may be close enough or may not be some cases. And the more and actual value is this minus and predicted value is this. So I can see my computer has predicted negatively. Actually, it was sold as a 13,500, but my computer predicted that it can be sold as a 14,663. My formula. So now I can apply that. So I can see all the predictive things. So I can plot the graph for these residuals. So now I can see we are closely matching with this. So this formula is valid.
Okay, so they use the residuals to plot the graph.
Yeah.
Do you use the residue to plot the graph?
Yeah. So you copy the residuals till the end and insert. Click on the insert. You have a something called charts. Yeah, charts. In the charts, you have a scatter plot. So when you click on that, you will get a residual scatter plot. So this shows that our predictions are very good because they all in a small range. So if it is increasing like this, our prediction is bad. So our prediction is this residuals how less they are, that much good our model is. Okay. So how close they are. If they are very close together, means that your model is going to predict very well. Okay. So this is the formula we have. So means simple. Same formula I can apply here. So I will copy the same things and the significant things. So I copy this entire thing because I want to know which one should I apply the formula. So I paste it here. So I know these are the coefficients. So I can predict. So now the formula is equal. So intercept the C value plus, and the same thing we do. So we have a M value, the slope and relation between age and the value plus, and I have a manufacturing month and manufacturing month, and I have coefficient, this one, multiply, and the manufacturing month plus, I have a kilometer also significant. Yes, I take the coefficient, multiply with kilometer plus. And I have a HP also is important, horsepower, and I select the coefficient and multiply with HP. I see the Met color is not there in my formula. It is not showing significant based on my analysis. So I don't put them in my formula. So what is important is my automatic thing and these four things. So automatic is important. So I take the significance, sorry, the coefficient and the automatic value plus. And I have a sports model is also important. So I take the coefficient. Oh, it doesn't take in me. Why is not taking me? So 3 is important and 1, 2, 3, 4. Did I put horsepower? Yeah, I put horsepower. Okay. So next one is automatic multiplied by automatic plus, and lamps, missed lamps coefficient multiplied by missed lamps value plus. So I have a sports modes multiplied by sports model plus. I have a backseat and backseat drive divider. So this is also important. So these parameters I map and I will freeze the coefficients. So I need to put F4 for the coefficients. This yeah, so B4, C14, these are the coefficients, M values. So I need to freeze them and E4, this one, this one,
Please,
this
when you
one.
say freeze, sorry, please. When you say
Yeah,
freeze, when you say freeze, what do you mean and what do you do?
means what we're doing is it's a when you drag this one, it is not going to change the coefficient values. It is going to change the next cell D B3 C2 instead of C. I will tell you. I will tell you. Wait. So 1 minute. Now you got. So if I want to apply the formula to this data, I can go and drag it. Okay. You got it. So here you see there is a B3 means this data, C3 and D3. But I didn't change anything for my coefficients. This is the constants which I got from my analysis, right? Yeah, so I don't want to change these cells in my formula. So in order to not to change these cells, you need to use a two dollar signs like this in the formula. So in order to make that, you can just click on F4. Select that and click on F4. You will understand. Let's see. So this is the two predicted values and this is the graph, scatter plot graph. And he want these two values, what is there. So what is advantage is, suppose I want to say mm, a model is 15 years old, month is ninth month it is manufactured, let us say 1,000 kilometers my car went. I have a 125 HP car. I have a matte color one. It is automatic. Let's say it is also having a radio. It is having a lamp and it is a sports model car. It is having back seat. It is having a rim. It is having a radio cast. Let's say it is having a parking assistant. It is having a two bars. So I have my car. I want to know what is the price it will go for sales. I can just simply, I have already had a formula. I just drag it and tell you, yeah, your car can be sold at 19,700. Simple. So this formula we made it from our analysis. So this analysis we got it from our regression analysis by finding which column is important and which column is related to the price column. So when you see the data, I have a 14 columns. So if car is having a more edge, what is the relation between the price it's going to sell? If it is a brand new car, it is going to sell more value. So I want to know the relation between these two and also relation between. So we did that analysis using the regression tool. This all the statistics of that. And these all the coefficients tells the slope between age and the price. So the age, suppose if age changes 5 years, how much for 1 year change, how much price it is going to change? For a manufacturing month, for 1 month price, 1 month change, how much price you going to lose? So for a 1 kilometer change, how much price you are going to lose? So these all are coefficients, so which is used to calculate our prediction. So, and the most important condition we take it as P. If P less than zero point 0.5, those values are more affecting my price. Means you see here my car price is impacted by age because the P value is less than 0.015. You see this. And my car value is impacted by more by kilometers. And if I see this, my car value doesn't impacted by whether metallic rim, radio castle, parking, two bars. It is not affected by. The p value indicates the relation between the price, the y-axis, and the relation between x-axis variables. So we put the condition and we know which one is important, and we found which is important. We take that data here, and we take the data, and we find out what will be the prediction using the formula. We have a intercept. So we again applied to this data, sorry, again we applied a regression to this data to see if the p-value is, any p-value is greater than 0.15. So when I do again on the data, no value is showing me less than zero point 0.5. So all are important. So these all columns are important. So I go back to the D1 and I took which columns are very important. So I took them here, and now I use the column values and coefficients and the constant like y equal to m1 x1 plus m2 x2, m2 m2 x2, and m3 x3, m4 x4, and like that, so on, and plus c value. So with that formula I got this. So the first point is which variable impacting your price. So that we found out from the regression. And we took those columns and we took the coefficients given by the regression model, and we took those coefficients and we multiplied using y equal to mx plus c. So these are the two values which we needed. This is the example data I took. I delete. So these are the answers. So thank you so much.
Okay, so that is all, Kishore.